Okay. Now suppose you want to find the limit of this. Okay. So what you will do? This is actually two variable function, right?
I
So
see.
yes,
Yeah.
the
Some.
function contains two variables. Okay. Here x is 0, y is 0. Okay. It means that line passes through origin.
Yeah.
Okay. This is very important, right?
Right.
X is 0, y is 0 means y is equal to mx. Any line which passes through origin can be represented in this way, right?
Yes.
Yes. So a function had two variable, you can change in one variable. How? X, right here mx. Then x square minus mx whole square, x square plus mx whole square, right? You can take x square
Um,
common from upside and right? So you can say this
yes.
is function of x. Okay. Now, uh, instead of finding limit in two variable, you can find limit in one variable also. How? Just put here y is equal to mx and change the function into one variable. You will get what? You can see this function is independent of x, right?
Right. Right.
If it is independent of x, you cannot put the value of x. So the limit will be what? Right?
Mm-hmm.
But you can see, yes, but you can see the value of m is anything. If value of m is 1, then you will get y is equal to x. If value of m is
Right.
1, let's suppose this is limit and it is represented by 0. Then L will be 0, right?
Right.
Okay. If m is equal to 0, then limit will be 1. If m is equal to minus 1, limit will be again 0. So you can see when the value of m changes, the limit is also changes, right? It means that
Yes.
the limit of this function depend on its slope. Okay,
Mm,
so you can say limit
I
does
see.
not exist. Okay,
I see.
yes. Why does not exist? Because you can see at m is equal to 1 and m is equal to minus 1. Both have same limit, which is not possible, right? And even you
Yes.
can also say the limit is depend on its slope. If slope changes, the limit will change. So you cannot find the exact value of L, right?
Yes.
That's why here it is written does not exist. Understood?
Yeah.
See one more example. Here x is 0, y is 0. Same problem. The line passes through origin, right? This
Yeah.
this can also be a line. This is y is equal to when slope is negative. So
Negative.
you
Yes.
can write minus 1. This is for positive slope. But in general, you can write y is equal to mx. M is what? Slope.
Mm-hmm.
It may be positive or negative. So replace y is equal to mx. You will get if y is equal to 0, then x will be 0, right?
Yes.
Cancel x square from both numerator and denominator. Again, you can see the limit of L is depend on its slope, right?
Slope. Yeah.
If the value of slope is changes, then limit will also change, right?
Yeah.
L does not exist. I think you understood this. You have already learned this,
Yeah.
right? In the previous
Yeah.
classes. Yes, yes, same thing, right? If the value of L is not unique, then you can say limit does not exist, right?
If the limit of L is not units, so
Not unique, unique.
unique. Okay. Yeah.
Yes. Because the value of limit must be unique.
I see.
Yes. See this. X is 0, y is 0. X is going towards 0, y is going towards 0. So y is equal to mx, right? When you put here, suppose this is L, this is x cube, take x square common. What will you get? 1 plus 1 plus m4x square, right?
Yeah.
Okay. X square cancel. Okay. On putting x 0, you will get 0, right?
Yeah.
Okay. Yes.
But what time we represent a function with two yeah, multivariate. Yeah, okay.
Yes.
So we have two inputs for the function. And we can have even more, right?
Yes. See, so when the limit, when suppose you guess that this limit passes through this line, passes through origin, then you are getting
Yeah.
0.
Yeah.
Okay. Now let's suppose
Yes.
this is first case. Case number 1 is what? At origin, L is 0. You are getting 0, right?
Uh-huh.
Now, when you are finding two variable limit, then you can also find in this way. Put x is equal to 0, y as it is. Okay. So here you will get x is 0 is what? 0 upon 0 plus y4. So 0. Case number 2 is what? At 0 comma my. L is 0, right? Okay.
Yeah.
So case
Okay.
number
Yeah.
3 is what? Put x a constant and y 0. So what will you get? Okay. When you put y 0,
0 over x which is
so
equal to 0.
0.
Yeah.
Okay.
Yeah, now, yeah, you are using the function xy square. I see. Now I see it. Like, I was looking for which function you are compensating in. Sorry, my bad.
Understood?
Yeah, yeah,
So in each case, you are getting L is equal to 0. I
I see.
think, I think this limit must be exist. Let me check. At 0, 0, you are getting 0. Okay. Actually, this limit is exist. Okay. The limit exists when the curve is line, right? In the question, it is saying that the limit is exist when curve is line. But when
Yep.
curve is a parabola, let's suppose this is
Mm-hmm.
mx square, then it does not exist. Why it is taking parabola? Because you can see here in second part y raised to 4 is there, right?
Yes.
So when x is equal to mx square, then it will be mx square whole square, right?
Yeah.
X square plus m square x whole square. So it will be x raised to 5, x raised to 2. Again, you are getting 0. I think this limit is exist, okay?
I see.
Yes. This in this part, it is solved using parabola, but always solved using line, okay?
Mm-hmm.
Okay. See, sum and difference rule, constant multiplication, product rule, and quotient rule. This is same as you have learned in first variable, one variable. Let's suppose three functions are there. F lies between G and H. Then the limit at G is equal to limit at H is same. Then L will be same. Suppose the limit of G is L and the limit of H is also L. Then the limit of F will be L. Okay?
Yeah, that makes sense.
Yes. Because F lies between G and H. What is continuous function in two variable? A function fxy is continuous at AB if its limit is same as if the limit of function at AB is same as function at AB.
I see.
Okay. Suppose the limit
Yes.
of x comma y at AB fxy is equal to 2 and f of AB is also 2. Then you can say they are continuous. Okay.
Yep.
Yes.